we did appearance tab full resolution. We changed the increase full resolution and display limit to 2,500,000, and the density we changed it into maximum. And we observe that detail shape, like the elevation and some of the bump, and we can see there are some different variation here, maybe some trees or something. An appearance tab LAS points filters. An emitted light pulse can be reflected from one or many features, so therefore the sensor can receive more than one pulse. We can use these different laser pulse returns to display the LiDAR data referenced by the LAS dataset. The most common filters are ground and non-ground, meaning ground return and feature return respectively. The ability to separate LiDAR data based on different returns allows us to analyze and visualize LiDAR data quickly and efficiently for various applications. And the LAS points filter menu provides a quick way to assess common LiDAR filters. We will explore those common filters. All points uses all the points to display the LAS dataset. The ground uses only the points flagged as ground to display LAS dataset. Okay, let's look a little closer. A non-ground uses all the points not flagged as ground to display the LAS dataset. And I'm going to change it and see. Appearance. I'm going to go to appearance. That may be symbology, elevation, intensity, and it didn't say anything. Let's see the filter text. Extend. Let's see, look at the returns. Cool. Let's look at elevation again. Okay. Elevation. All points use all the points to display. It didn't show us ground, use only the points. Okay. Okay. Close. So the points, we can see all points is right here. All points filter. Okay. And let's see ground. Non-ground. My color scheme is a little weird. First return points. Let's look again. This is ground, non-ground, and first return points. And now we can use different functions of the appearance tab together. So if the LAS point are first filtered to ground and then displayed a surface elevation, a digital elevation model DEM is shown. A DN is a representation of a continuous surface reference to the Earth and representation elevation. So let's look. Surface restraints. We do not have any. DEM. If the LIS points are first filtered to non-ground and then displayed as a surface elevation, a digital surface model is shown. A digital surface model shows the elevation of the Earth's surface object that have elevation above the Earth's surface. So let's change it again. Ground. Appearance tab, combine functions. A surface elevation, a digital elevation, okay. A DEM is a representation of continuous surface. Okay, and then we have data percentage, and we can see the data percentage, and we can show all points. All points. Okay, and go to property. Everything showed up, okay. And ground. Okay. And we will do a deliverable 3D scene to view LiDAR data in the 3D dimension. Convert a map to a scene that we will have to transform to, it should be in view. We will convert to a 3D, convert map between 2D and 3D. Yeah, it's right here. The maps are representations of reality and include information to enhance the understanding of the world around us. Two-dimensional maps can incorporate a third dimension through contours, hill shading, and profile view elements, but ultimately 2D maps are limited in the amounts of vertical information they can convey. In cases where the vertical axis is important, ArcGIS Pro includes the ability to tilt the 2D map and view spatial relationships in a 3D scene. And this process makes the data more understandable and helps reveal new insights. ArcGIS Pro includes the following viewing modes for scenes. Global mode is used for a large extent real-world content where the curvature of the Earth is an important element. Local mode is used for smaller extent in a projected coordinate system or in cases where the curvature of the Earth isn't pertinent. One of the main features of ArcGIS Pro is its integrated 2 to 3D environment, which allows us to simultaneously view the data maps and a scene. We can quickly switch between maps and scenes as well as link them together for synchronized viewing. In the old version, we have to do is ArcMap and ArcScene. On the View tab, we click Convert, which is right here, Convert. And the catalog pane will expand maps. So now we have a map 1 and map 2 here. Now it's generating for 3D. We're going to wait a little bit. And I'm going to name this Baltimore LiDAR. Excuse me. And we will right click on this one and open Global View. Properties. And we will explore tools to allow to navigate with a 3D scene show here. Need to zoom to layer. Data is not showing up. We have to see what's going on. Is it still rendering? Buildings are right here. I guess maybe we just have to wait a little bit. Right now, nothing shows up. And we will turn off all the layers except our buildings. Okay, this thing. And we will write this. Zoom to layer. Okay. Wait a little bit and see what's going on. I'm going to save it. Global view. Okay. And we will write a paragraph about the appearance of the data visualized in 3D, particularly addressing the structures that we can see more easily. And then we will add height to the buildings. One of the benefits of LiDAR is that height of buildings can be extracted and then assigned to the building polygons. Then we will turn to the Baltimore LiDAR map, so we are looking at the data in 2D. Okay, we will add a height. My building is not showing up. That really is frustrating. Okay. And analysis toolbar, we will go to tools and search for LAS. Okay. LAS point statistics by area and 3D analysis. And we open this LAS point statistics by area tool, and we will use the parameter, the data set. We will load this input polygon. It will be buildings. And output property, maximum Z. Select. And I guess I can just run it. Then we can open the attribute table. We should have a Z value here. And buildings, right click on it. Okay, open attribute table. Let's look at the Z value. There. Now we have a Z value, we can write a paragraph about the process used to create a building height. And we could extrude the building footprints. And back in here, 3D, and we will select buildings. Once I select buildings, okay. This thing is not showing up. If it's not showing up, then nothing are there. That's crazy. Okay, on the Appearance tab, I select my buildings, Appearance tab. Then I will go to Extrusion. Extrusion, then type it will be maximum height for the building. Okay, and field, it will be Z max and US feet. Okay, I think it's rendering. Close this out. Something wrong is here. Going to convert a new 3D. And I will show the height again. Hopefully we can export. We just have to see how those data responding, and I don't think it's doing it. My layer is not showing up, and I have to figure it out. What's going on? Okay. Choose buildings, appearance, type maximum height, and the field will be Zmax, or just Z. Where are the buildings? How come I have 2D layers? Can I remove them? That's interesting. I don't need water, and I'm going to remove this as well. I don't need. Okay, now in this case, let's do analysis view, convert it to 3D again. Appearance, maximum height, Z. Now we can see the building. It's just the color. Okay. The same one, this should be, yeah, it's for all here. I don't need those. Remove. Okay, I think the appearance, because I show ground, that's why. Now I'm gonna change all those points back. My data. Okay, all points. It's going to take some time to render. Right now it's all ground. I'm gonna change it into all points. Okay. All points. It's gonna take a while. I messed up. The building, did I extrude the building yet? This is not maximum. I'm going to remove everything. Remove. Okay, remove. And once I do the new layout, I will 3D. Okay. And we will save as a PDF. We need a north arrow. We don't need the building and other things. And then we will do San Francisco. I went there 2016. It's really nice that we could do something for San Francisco. And we just use the LiDAR data. And we could do the classification for the 3D LiDAR. It's not perfect, but it's interesting. It's interesting to see the visualization for the data. How would you present your data and add your data there? And next, tomorrow we will do the 3D for picking up some of the campus, and the final chapter is looking at where we should put out the solar energy. Okay. And forest vegetation height, and then solar panels also deal with the LiDAR data. And now, let's see. Just go back and forth, go back and forth. Do not show this. Okay. Show my building. Now I have all points. Okay, let me double check again. Nope. Click OK. I need all points. There. Oh, right here is all points. We can save these. Okay. Don't save it. Okay. Let's see maps. Okay, those maps are already created. That's fine. Let's see, what is this map? That's fine. Let me convert it again. View, convert. Yeah, here is all points. I don't know what is the red thing. The elevation cannot add to 3D. Let me extrude. The color is there, but not all the points. Let me go to building first. Let me extrude building maximum height, and then z-score. Here we are on 2D. Let me remove this and view. Convert again. The 3D thingy. Okay, this layer is here, okay? And let me extrude the building. Building, we go to appearance, maximum height. I'm going to close this out. Just takes a lot of things. Nothing shows up. Alright, click on it and go to zoom to layer. Working with 3D computer is really slow because I think I added on things. Zoom to layer. I extrude the building, and sadly the one layer is not showing up. I just don't understand why this layer is not showing up. Let me go to appearance and see what's going on. Something is going on here because this layer is not showing up. And deliverable for a 3D layout to export as a printable PDF. After completing the deliverable, we must choose a method of representing the conclusion. Remember that the audience may not share the GIS expertise here. In this case, we will present a layout showing a 3D view of the results. In a layout 3D scene, portrays 3D data on a printed 2D page. We can add static and dynamic elements to the page and support the scene. The layout can also be exported in a variety of graphic file formats, presenting conclusions. We could put in a new layout and ANSI portrait letter. Insert the north arrow, insert a title, and export as a PDF. Now nothing shows up here. Oh, I have to use as a point. Let's do maximum. Some parts didn't match the data. Okay. And then I'm going to spin around. I'm going to add base map imagery. Okay, then I'm going to insert map new layout. Okay, map frame. Map frame. This time for map frame we are choosing the Baltimore. Okay. And that's weird. I'm going to activate the map. Okay, I'm going to activate the map and see. Activate. Okay. And come back. Let's see what's going on for my points. Okay, I will choose this one. And appearance. Yeah, I already moved it to maximum. We converted 2 to 3. Okay. Open the global view or double click this to open it. Oh my god. The vertical extrusion, that's too crazy. If I change it into 2. Just 1. Click OK. Let me activate the map and change. Oh, my buildings. Yeah, I can change some color for my buildings. Okay. Layout. And right click on here. And go to symbology. Okay. Unique values. Z. Yep. Loading symbology. I think that's what they did it here. Using different colors and showing the buildings. Let's see what kind of buildings are now. Okay. Using some nice color. And I need to get rid of the outlines. Oh no 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 no, why it's all just one color? I don't want all other one. Okay, do not show these. And for the symbology, I don't think they showed this one. Let me move it down. Okay, let me move it down. They didn't show this. And my buildings, let's see what kind of color. Yep, different colors. Okay, that looks nice. Close this out. And for buildings, no outlines, obviously. Okay, no outlines. Okay, I'm going to activate it again. Cool. Okay, the only thing is I'm going to open symbology. I don't want the outline, so. Oh my god. I don't want to change it one by one, so no color, click apply. Can I just apply to all? Go back. There are so many. Z for sure. Let's just look the symbols, okay? Let me save it first. The building. Let's do graduated colors. Use a different color. Ramp. Field. Okay, so I could do maybe 10 there. And I will change it. Okay. No outline. 10 is a lot easier to manage, okay? I could do yellow. No, not the outline. Yellow and, yeah, yellow and yellow. And back. And change some to green. Green to green. Click apply. Oh my god. Okay. Nope, I still have to change a lot because of the outline and stuff. Symbology. This one. Okay. I will change a little lighter blue. I will do lighter blue. Click apply. I think 10 colors would do. It will look really nice. Okay. Back. I don't see the yellow yet. Okay. And light blue. Okay, this blue, and then I can do dark blue. Apply. Go back. Okay. We will do this one. We will do this one. Click apply. Go back. There. And it does look a lot nicer without the outlines, okay? Okay, then the green, I think I did the green. And this one we will do a lighter pink and lighter pink. Click apply. And let's go back. Okay. And we will do a darker blue. And we can do red. 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 Okay, it's just a little time consuming doing one by one, but we want the final format look nice now. And this time I will do yellow again. Because I really do not see the yellow. And after yellow, I will do a little pink. We will have to see what color is available there. Or I can do gray. Yeah, I do think I can do gray. The last one I will do gray. Or brown. Yeah, I want to do brown. Or just gray. I still can't see those building lines, which I really do not like. Oh, I really do not like the color. Let's do light green. Okay. So now I'm going to add a north arrow. Okay, now back to layout. Insert north arrow. Just this one. North is here. Okay. Dynamic text. Dynamic text. Source. There. Going to move out this thing. Okay. Well, I don't like it. I'm gonna delete it. So I'm going to select these and oh, I cannot. Okay. It's okay, then I will just do nothing. Because it's not 2D and I cannot bulk mold. It's not 2D that I cannot line up with the 3D. I really cannot do, because here is on the sky, it's not 2-dimension, it's 3-dimension. So it will be difficult. Okay, I'm going to do 22 and bold it. Well, I can do maybe 26, 28, maybe 33. There, I like it. Okay. Now Baltimore LiDAR 3D. It's really nice. Okay. That's the 3D. For visualization, and it actually just for visualize. We didn't do any research, or basically we just look at the points and how the points react. Nothing new. All right. Nothing special, and the building, even we turn on this and you can see that it's quite different. It's quite different, and the bubble and the dots are just looking weird, and I really do not like this research, as you can tell. And I'm going to see I'm going to activate the map. Once I activate the map, I select these and appearance for this layer, and I could just do ground points. Let's see, click OK. Let's just move it to ground and see what's going on here. Oopsies. It's really weird. Non-ground, let's see, non-ground points. Oh, this could be interesting. And you can see how it changes. And those are non-ground, but non-ground, and you can see some area detects. And here we know there are some canopy with the trees. That the shape got cut. But if we zoom in, then here we have the tree, you know. That's very interesting. Going to turn. I'm gonna spin a little bit. Control B. Okay. There. So we can see the other area as well. Turn the other side. Zoom out a little bit and drag it. I can do a diagonal. There. and off, on and off. Yeah, nothing shows, so. Oh, we can turn on those little bubbles. Okay, that's cool. And back to layout. It's really nice. Okay, it's fun. Okay, but I don't really see what is the usefulness here. Okay,